So I realized in the last video that we didn't quite have enough time to cover number 5. So we'll start off with number 5 in this video. All right, so as you look at this triangle, again, ask yourself, what do you know? So you'll see that you only know one side, but you do know one of the acute angles as well. So tangent, sine, cosine, and tangent is going to be what is best to solve in this triangle. So you do need to solve both of the two missing sides and the missing angle. Let's start with the missing angle. So with a 22-degree angle here, doing the 180-degree calculation, you'll be able to find that measure of angle E would be 68 degrees. Okay, now let's choose one of the two sides to work on. So let's choose EF first. I'll just go ahead and put an X there. So I'm going to focus on angle 22. This is the one that I'm going to be looking from. So from angle 22, X would actually be the opposite side, and 12 would be the adjacent side. And the trig ratio that deals with opposite and adjacent is tangent. So I'm going to write an equation to help me solve this. So tangent of the angle that I was looking at, which is 22 degrees, is equal to the opposite side over the adjacent side. So tangent of 22 equals x over 12. We need to solve for x. So in this case, it's very easy. We just multiply by 12 on both sides. So x will be equal to whatever 12 times the tangent of 22 is. And remember, whenever you're dealing with sine, cosine, and tangent, you're going to have to use your calculator to do the solves on these, because your calculator holds all these ratio values in it. So that comes out, if you evaluate that, it comes out to approximately 4.8. The length of side EF is 4.8. All right, let's move on then to the length of DE. Now, when you look at DE, that's the hypotenuse side. Well, it's the hypotenuse side no matter what angle you're looking at. So again, I'm going to focus on the 22-degree angle, the hypotenuse side, and I'm going to use the 12, so the adjacent side. So the trig ratio that deals with the adjacent and the hypotenuse is cosine. So that would be cosine of the 22-degree angle is equal to the adjacent side, 12, divided by the hypotenuse side, which is y. All right, so this one takes a little bit more to solve because of the variables in the denominator, right? So we're going to have to multiply by y on both sides, which would give us y times the cosine of 22 is equal to 12. And then to get y all alone, we're going to divide this value over. So divide by the cosine of 22. So y is going to be equal to 12 divided by the cosine of 22. And again, you'll have to use your calculator to do this. And that comes out to be approximately 12.9. Let's move on to question 6. In question 6, you can see that we, again, only know one side, but we do know one of the acute angles. And lo and behold, that acute angle is a special angle. Let's calculate the measure of angle A quickly. 180 minus 90 minus 30 would give us the measure of angle A is 60. So this is a 30, 60, 90 triangle. We're going to use the relationships that we know of for a 30, 60, 90 in order to solve this. So first we need to know which side is this one that we know. So if you check it, you know, this side is the hypotenuse, right? And between these two sides, this one is the short leg, and this one would then be the long leg. So we know what the long leg is, and we know that the long leg has a relationship with the short leg. If you remember, it is the short leg times the square root of 3, and that will equal the long leg. So we just need to plug in what we know and then solve out. So if we called the short leg x, that would be x times the square root of 3 would be equal to the long leg value, which is 12. So solving for x, we would need to divide by the square root of 3, so we would get x equals 12 divided by the square root of 3. That's your 80% answer. If you want a 100% answer, you need to rationalize the denominator. Make there be no root in the denominator. So I'm going to multiply on the top and the bottom by the square root of 3. So on the top we get 12 times the square root of 3. On the bottom, square root of 3 times square root of 3 comes out to just be 3. And then of course you see that the 12 and the 3 can cancel, making this 4 square root 3. So the length of MA is 4 square root 3. And now the rest of this is super easy, because the relationship between the short leg and the hypotenuse in a 30, 60, 90 is just a 1 to 2 relationship. The hypotenuse is just 2 times the amount of the short leg. So 4 square root of 3 times 2, hopefully you remember how to do this. You would just literally multiply the number outside the square root times the 2, and that would come out to be 8 square root 3. Right. These problems can take a very short amount of time because these relationships are already known. And again, this is a problem you do not need a calculator for, and you're actually not allowed to use a calculator for. Let's move on to number 7. For this one, you'll notice that 2 side lengths are given and no acute angles are given. So this brings us back to Pythagorean Theorem. Anytime you have 2 side lengths and you just need to find a third side length, you can always use Pythagorean Theorem. So leg squared plus leg squared equals hypotenuse squared. Very important to recognize which one is the hypotenuse. I see a lot of students, they'll just do this one squared plus this one squared equals the unknown one squared. But you always have to make sure the hypotenuse is the one that's alone. Okay, so we'll just put in an x here. That would be 2.7 squared plus x squared equals 6.5 squared. So now we need to get x alone. So I'm going to subtract the 2.7 squared over to the other side. That gives us x squared equals 6.5 squared minus 2.7 squared. Now at this point, if you want to, you can calculate it, or maybe you've already calculated what that is. But this value comes out to be 34.96. So then, if x squared is equal to that, x would be equal to the square root of that. And that's something you can use your calculator. Well, actually, you could leave your answer like this if you wanted to. But in this case, because we're dealing with decimals, decimals aren't that easy to calculate by themselves. So I will let you use your calculator if I were to give you a problem like this on the test. So the square root of 34.96 comes out to be approximately 5.9. All right, now let's go to the issue of the acute angles. So hopefully you've figured this out by now. Anytime you need to know one of the acute angles of a right triangle, you've got to use inverse, sine, cosine, and tangent. So I'm going to look at angle x. I'm going to solve for angle x first. And I can pick any 2 of these sides that I want to. So maybe I'll switch things up a little bit this time. I'm going to use the 5.9 and the 6.5. So if we're looking from angle x, the 6.5 would be the hypotenuse. 2.7 would be the opposite. So then 5.9 would be the adjacent. So I'm just going to use the adjacent side and the hypotenuse side. The trig ratio that deals with those two is cosine. So normally it would be cosine of angle x would be equal to the adjacent side 5.9 over the hypotenuse 6.5. Because we're missing our angle, we need to switch this over into cosine inverse, and we need to put the ratio inside instead of the angle. And whatever that comes out to be will give us our value for the measure of angle x. Let me calculate that very quickly. It comes out to be 24.8 degrees. Remember, once you solve for one of the angles in the triangle, one of the acute angles in the triangle, the other one can just be solved using the 180 degree relationship. So 180 minus the 90 minus the 24.8 will give us angle Z, and that comes out to be 65.2 degrees. Let's move on to the last question in this section. All right, number 8 gives us one of the acute angles, gives us one of the side measures. So notice the degree measure they gave us is 55 degrees, which is not a special angle. So this one's going to be a question that we use sine, cosine, and tangent for. So first thing we can do is solve for the measure of angle G using the 180 degree relationship. 180 minus 90 minus 55 degrees would be 35 degrees. All right, now let's solve for, well, let's call this side X and we'll call this side Y. So let's solve for HI first. All right, now you do have to choose which angle you're going to look at. I tend to usually choose the angle on the left side. I don't know why, but so I'm going to choose the 35 degree angle. So if we're looking at the 35 degree angle, the X would be the opposite side. This side GI would definitely be the hypotenuse because it is across from the 90 degree angle, and that means that this side would be the adjacent side. So let's solve for X first. We need to figure out which trig ratio uses the opposite side and the hypotenuse side. So that would be the sine ratio. So sine of the angle I'm looking at, 35 degrees, would be equal to the opposite side, X, over the hypotenuse, which is 20. Solving for X here, just multiply by 20 on both sides. So X is going to be equal to 20 times the sine of 35. Get your calculators out. Check that answer. If we round it off to one decimal place, this answer is going to come out to be 11.5. Now we can solve for GH using the same idea. We might have to change our trig ratio though. So again, I'm going to stick with the 35 degree angle. Now we're looking for the adjacent side, and I'm going to stick with using the number that I know for sure. Like this is a rounded answer, so I'm not going to use this in my solution process. I'm going to stick with the 20. So which trig ratio uses the adjacent side and the hypotenuse side? That would be the cosine ratio. So let's set up another equation. Cosine of the angle I'm looking at, cosine of 35, is equal to the adjacent side y over the hypotenuse side. Again, we just multiply by 20 on both sides. So that gives us our solution. Y is going to be equal to 20 times the cosine of 35. So type that into your calculator. Rounding off to the nearest tenth, that would give us a value of 16.4. All right, that finishes up the first section of the review. The next section we'll move into some different problems, so I'll start a new video for that section.